Good morning, students. So myself, Vijay Shankar from EC Department, Chippewa Engineering College. Today, we are going to discuss about another topic in the fourth unit, analysis of linear system. In previous class, we discussed what are the different types of systems and again, how many types it is divided or further is classified. We already discussed that is one is a linear time invariant system for the linear system. You can see some examples in the linear time systems. See the signal transmission through the linear system. You know the system is said to be, the system is defined as a set of rules that associate with an output time function to every input time function. So we already discussed this one. System with having the input excitation f of t, the output response is the y of t or x of t, whatever it is. Here they wrote it is a r of t. Okay, and the system is classified in the two types. So one is a continuous time and a discrete time. That continuous time and the discrete time also is both is again is further divided as a static, dynamic, and linear, non-linear, time invariant and time variant. Linear system, stable system, causal and non-causal system. Okay, we know. See the a linear system means if any signal f1 of t multiplying with the a1 f1 of t, and another signal you can take f2 of t with multiplied with the a2, and the signal is a2 f2 of t. Add the two signals a1 f1 of t and a2 f2 of t, add the two signals and then given to the system. The h is nothing but to get the system. Okay, system to get the response is y of n. Okay, or the y of t in terms of the frequency is equal to, and the first signal f1 of t is given to the system to get the response, and f2 of t also, before adding the two signals you can give the two signals through the system, passes through the system, and then you can add a1 h of f1 of t and plus a2 into h of f2 of t, or f of t, f of x of t, the representation of the signal which is passes to the system, output response signal, whatever it is, the representation is different. If both are equal, system is said to be the linear system. The system which does not obey the above principle is called the non-linear system. Okay. So the definition here, a system is said to be the linear if it satisfies the superposition principle. It states that the response of the system to a weighted sum of the signals be equal to the corresponding weighted sum of the outputs of the system to each of the individual signals. So the combine the equation and is equal to the individual weighted signals, the a1 into h of f1 of t and a2 h of f2 of t is equal to h of adding the two signals. Okay. See the examples on the whether the given signal is linear or not. Okay. Check for the linearity. The procedure is apply the different inputs separately and get the output. Apply different inputs simultaneously and get the output. If both the outputs are same, it is linear, otherwise it's a non-linear. Apply different inputs separately and get the output. This one. The first diagram what they are showing here, apply different inputs separately and get the output. Apply different inputs simultaneously and get the output. If both are equal, then that system is a linear system. Example, y of t is equal to 4 into sine t x of t. The given function is y of t is equal to 4 sine t x of t. the signal is a linear or not. We can find out that one. The first one, let the y1 of t is equal to 4 into sine t x1 of t, because I am assuming the y1 as a output with the input of x1. Similarly, the y2 of t is equal to the output y of t, getting y of t with the input of x2 of t, sine t x2 of t. Now combine the two equations of y1 of t plus y2 of t is equal to 4 into both the terms having the 4 is a common and sine t is also common, and x1 of t plus x2 of t. Got it, my dear friends? Or this is the first step one. Apply the different inputs. One is x1 and the x2 inputs separately and get the output. And second is apply different inputs simultaneously and get the output. So what is the y of t? Directly I am taking the y of t is equal to the 4 into sine t. Add the two terms before giving to the system. Before giving to the system, add two signals and get the response. Okay. Is x1 of t plus x2 of t. So both are the same. It's a y of t. Let us take the y of t is equal to the combination of the two signals. So y of t is equal to the response is the same. Individually you can add, or before giving to the system, add the two signals, get the response. Before adding, give the two signals pass the signal to the system. Both will get the same response. Then that system is a linear system. So S1 is equal to S2. Okay, so a little bit confusion. You can see the second example, then you can understand what is a linear system. So here I'm taking another example, the second example. See, what is an example here? Y of t is equal to a into x of t. So y of t is equal to a into x of t. So here also, by the input of x1, the response is a y1. And by the input of x2, the response is y2. Combine the two functions, the output response y of t is equal to y1 of t plus y2 of t, that is equal to, both having a is a common term, a into x1 of t plus x2 of x1 of t plus x2 of t. Okay. Or otherwise, directly can add the two functions, then give the a as an input to the system, get the response y of t is equal to a into x1 of t plus x2 of t. Okay, my dear friends. So the y of t, let this is a S1 and this is a S2. So S1 is equal to S2. The system is a linear system. For the signal y of t is equal to a into x of t. Okay, my dear friends. Next, third example, y of t is equal to x square of t. So this is a third example. Y of t is equal to x square of t. Now we can understand. What is y1 of t? Y1 of t individual if I am taking y1 of t is with the input of x1, x1 square of t, and y2 of t is equal to x2 square of t, and add the two signals. Y of t is equal to y1 of t plus y2 of t, that is equal to x1 square of t plus x2 square of t. Okay, let this as a S1. Now, what is a S2? S1. S2 means before giving to the signal is applied to the system, you can add the two signals. The y of t is equal to x1 of t plus x2 of t, and the total signal is a square now. Got it, my dear friends? Here the given signal is x of t. The x of t is equal to the combine the equation, the x1 of t and x2 of t before giving to the system. What is the function given? The y of t is equal to square of the input signal. As the input x1, signal is given to the system and get the response is y1. So x1 square directly here. And the signal x2, give it to the system and passes through the system, x1, x2 square. Now, the signal is x square of t. So before giving to the system, we are adding the two signals x1 and x2, and we are getting the response of y of t. So now, what is x1 plus x2 whole square means? X1 square of t plus x2 square of t plus 2 into x1 of t plus x1 of t into x2 of t. Okay. Now this is S2. Now compare the two functions. S1 we got x1 square of t plus x2 square of t on. But S2 is the additional term, we got the 2x1 and x2. So then the system S1 is not equal to the S2. So non-linear system. See here. Given the signal y of t is equal to x square of t is a non-linear system. Got it, my dear students? Now, the other example, the non-linear system, y of t is equal to e power x of t. The function given, the y of t is equal to e power x of t. And this signal is passes when the signal assuming the x1 of t, the function will get the e power x1 of t. And y2 of t is equal to, with the input of x2 of t. Then we can add the two signals, y of t is equal to e power x1 of t plus e power x2 of t. Okay. Let this S1. Before giving to the system, we can add the two signals. The y of t is equal to S2 is y of t is equal to, here the e power x of t is equal to as x1 of t plus x2 of t. Okay, my dear students. I'm giving the individually here, and then you can add. Now, what is the y of t is equal to the x of t? Before giving to the system, you can add the two signals x1 and x2, then pass through the system, you'll get the response y of t. Now, what is the function here? The e power x1 of t plus e power x2 of t. The power is added means e power x1 of t multiplying with the e power x2 of t. Let this is S2. So see here, e power x1 of t plus e power x2 of t is S1, and e power x1 of t multiplied with the e power x2 of t. So s1 is not equal to the s2. So this is the given function y of t is equal to e power x of t is non-linear system, the fourth one. Now we got one idea how we can find the linear system and the non-linear system for the given function. Okay. Next, you see the another example. We already know the t into x of t, that is a linear system only. And previously we see that the sine t x of t, wherever it is a sine t, the x1 and x2, the t into x1 of t plus x2 of t, and we will get the same function, the linear system. X of t square. Okay, we've seen that it is x square of t. The total signal is a square, but now if I am taking the x of t square, the time is squaring, and here the signal is squared. Signal squared is a non-linear system, but what is the time squared in that signal? Okay, let us take the y of t is equal to x of t square is a given function. So let the input is x1 of t to get the response y1 of t. So x1 of t square and y2 of t is equal to x2 of t square. Then you can add the two functions, the x1 of t square plus x2 of t square. Let this function is a s1, and the y of t is equal to, before giving to the system, we can add the two functions, that is x1 of t square plus x2 of t square. That passes to the system to get the response y of t. Nothing but it is a s2. So both are equal, and that system is a linear system. So what is that? Y of t is equal to x of t square. But x square of t is a non-linear multiplication here. X square of t is a non-linear function. Got it? Next, another example. Y of t is equal to x of t minus t naught. It is also a linear function because there is no any the square terms and there is no any exponential term here. Okay. Then we can understood a non-linear function. Let this cos of x of t. Okay. Cos of x of t. Let the y of t is equal to, ninth example, my dear students. Y of t is equal to cos of x of t. Now I am individually checking that the input x1 of t, getting the response is y1 of t, and input x2 of t, its response is y2 of t. Okay, so individual signals are passed to the system. Then after we can add the signals. That is y of t is equal to y1 and y2. Cos of x1 of t plus cos of x2 of t. Let this one s1. Now, before giving to the system, you can add the two signals. Then you can give the y of t is equal to, and before only you can add the two signals, means cos of x1 of t plus x2 of t. Add the two signals, then that signal is passes to the system, get the response is y of t. That this function is a s2. So observe here the cos x1 of t plus cos x2 of t, and here the cos of x1 of t plus x2 of t. So s1 is not equal to the s2. Okay. The system is a non-linear system. What it matters, students? Then another example you can see here, the y of t is equal to a into x of t plus b. Y of t is equal to a into x of t plus b. So individually, the signal is passes to the system. Definitely, you'll get the y of t is equal to, on time is a x1 of t plus b plus a x2 of t plus b. Okay, my dear students. Then the signal is a, take the common of a, x1 of t plus x2 of t plus b is the 2b, my dear students, 2b. But what is the second one? Let us say this is the S1. And what is the second one? Individually passes through the system, and before passing through the system, the signal is added a into the x of t. Now I am taking the x1 of t plus x2 of t plus b. Now you see the a into x1 of t plus x2 of t plus 2b is got when we pass the signals individually, and then we can add, but here we'll get the only the b only. Okay, S2. Therefore, the S1 is not equal to the S2. The given signal, the y of t is equal to a into x of t plus b, is a non-linear system. It's a non-linear system. Got it, my students? Then we go for the another function, the time variant and time invariant system. In the last class we discussed about this one, and I can see the some examples on this. What is the, first of all, you can know what is a time variant and time invariant. I already explained that a time invariant system means if the input is delayed, the output is also delayed, then the system is a time invariant system. The time variant means if the output is not delayed, even if the input is delayed, means x of t minus t naught, if the input is delayed, the output is also delayed, means the system is a time invariant system. If the input is delayed, the output is not delayed, means the system is a time variant system. Okay. A system shifted to the input results in the same amount of time is shifted in the output, but the wave shape does not change. That is, the input and delayed with the t naught, the output characteristics does not change with the time. Any system which does not obey the above principle is called the time varying system. Okay, and now let us go for some examples of the time invariant and the time variant systems. The first one is you can check the time invariant, shift the input only and get the output. That is the first step you have to do. Shift the entire system and get the output. See, first of all, you can do that. First step is shift the input only and get the output. Shift entire the system, means entire the given function, and get the output. If both the steps are identical for the output, then it is a time invariant system. Time invariant system. So you can take the first example. Y of t is equal to 4 into x of t. So y of t is equal to 4 into x of t. let assume that the signal is delayed here. The S1, let us take the S1 is equal to, the input is delayed, only the input is delayed. Shift the input only and get the output. Let that S1 is equal to, the Y of t is equal to, I'm taking the input is only delayed. So X of t minus 1, one sample is delayed. Then for the second one, replace, remember that one, to find the, shift the entire system and get the output. Means for the second one, replace t is equal to t minus 1. Wherever the t is there in the given entire the function or the entire the system, shift the entire system. So y of t minus 1 is equal to 4 into x of t minus 1. So wherever the t is there, you can replace with the t minus 1. Now can observe the two equations. The y of t is equal to, after even if the input is delayed, the output is also delayed, means time invariant system. Time invariant system. Both are equal. Okay. So remember this procedure to find the time invariant. Shift the input only and get the output. Shift the entire system and get the output. If both the steps are identical for output, then it is a time invariant system. Got it, my students? Now, let's take the second one. The y of t is equal to, 4t x of. Is it a function given? Now, what is the first step? Shift the input only. So y of t is equal to, what is the input means? X of t. The 4t x of t minus 1. So I use that. The first one is shift the input only, the x of t minus 1. Let this is S1. So we got the y of t is equal to 4t x of t minus 1. Got it? Now the second step, shift the entire system and get the output. Entire system is replace the t is equal to t minus 1. Why it is a t minus 1? You can shift any number of samples. I take that here only the one sample. So y of t minus 1 is equal to 4 into t is replaced with the t minus 1 and x is also the t minus 1. So now these two are not equal, my students. So now let us use S2. Therefore, S1 is not equal to the S2. So system is time variant system, not the time invariant system. See here, the second one, time variant. Both the S1 and S2 is not equal. Input is delayed, the output is also delayed, means you have to get the t is also delayed function. Got it? The second, you can take the another example. If I use the a into x of t. Third example, you can see my students here. The y of t is equal to a into x of t. So a is a variable only. There is no any change in this a. A is a constant, simply saying that. So our variable you can assume, but it is not related to the time. So y of t is equal to, if the input is only the, shift the input only, x of t minus 2. Let us take, I have taken the two samples and replace the t is equal to t minus 2. Now y of t minus 2 is equal to, there is no change in the a is an amplitude scaling factor only, x of t minus 2. So both the functions, let this S1 and this S2, both the S1 is equal to S2. Then the system is a time invariant system. Even for the a into x of t plus b also, but in the previously the linear system is not satisfied the linear system because the plus b is there. But in this, the input is delayed, the output is also delayed, then we can say the time invariant system. Okay. Here the y of t is equal to a into t minus 1 plus b. A and b are the constants only. Okay. And the y of t minus 1, wherever the t is there, you can replace the t minus 1. You get a into x of t minus 1 plus b. For the same function, the linearity, it's not a non-linear, it is a non-linear function. And now it is a time invariant system. Now, another example, the fifth one you can see, the y of t is equal to 5t x of t whole square. Okay, my dear friends. What is the first step? First step is input is only delayed. Shift the input only and get the response. 5 into t. Now I'm taking the input is delayed with one sample, x of t minus 1 whole square. And in the second step, the entire system is delayed. Entire system is delayed means t minus 1 and 5t minus 1. Wherever the t is there, you can replace the t minus 1. X of t minus 1 whole square. Now the first step and the second step is not equal. That this is S1, assume, and the assume S2. S1 is not equal to the S2 because it is multiplied with the t minus 1, not the t. So time variant system. So time variant system. Sixth example, you can see the y of t is equal to x of t plus 1 e power minus t. Okay. First step we have to see only the input is delayed. The y of t is equal to x of t plus 1 is delayed with one sample, x of t plus 1 minus 1 e power minus t. In the second step, the entire system is delayed. Replace that the t is t minus 1 is equal to, and here also I am replacing the t as t minus 1 plus 1. So previously I am shifting the sigma t plus 1 minus 1. Now it is a t minus 1. We are replacing the t as a t minus 1 plus 1. Both are the same, but here exponential is multiplied e power minus of t minus 1. Okay. Now these two are not. Let you take the y of t, here the x of t plus 1 and minus 1, and here also the x of t plus 1 and minus 1, and becomes of e power x of t into e power minus t. The first one is x of t e power minus t as S1, let us take. And S2 is the y of t minus 1 is equal to, is also the x of t e power minus t, and it is multiplied with the e power minus 1. But the time varying functions is the same, x of t into e power minus t. Okay, is a unwanted signal is multiplied, but the value is a constant value. Okay, here the t minus 1, the t is delayed here. But in this function, there is a x of t in e power minus t and x of t e power minus t. So both are the same, that we can call it as a time invariant function only, even if it is a multiplied with the e power minus 1 also. It's a constant. Got it, my dear students? Now you can understand how you can find the time variant and time invariant and linear and non-linear systems for any given function. Okay. And another example also, the three examples are remaining here. The y of t is equal to x of t plus 3. Y of t is equal to x of t plus 3. Now, in the first step, input is only the delayed, the x of t plus 3 minus 1, nothing but x of t plus 2. Let this say the S1. And second step, shift entire the system y of t minus 1 is equal to x of replace the t as a t minus 1 plus 3, and it is also equal to the x of t plus 2 only. Let this S2 assuming, so S1 is equal to S2 time invariant function. Okay, this is a time invariant one. So take the other example, the y of t is equal to x square of t. X square of t. In the previously, we find the linear and non-linear system. This signal is a non-linear signal because the total signal is in square of the function x1 and x2 square plus additional term also we get the 2 into x1 of t and x2 of t, then we can call it as a non-linear system. But in the time invariant and time variant, only the t is changes. The first of all, the first step we can do, the input is only the delayed x square of t minus 1. And in the second step, entire the system is delayed. T minus 1 is equal to x square of t minus 1, which means a replace of t as a t minus 1. Both the functions are equal, the time invariant system. Got it, my students? And here the another function, the y of t is equal to e power x of t. So in the first step, we can take the input is delayed. X is the delayed x of t minus 1. And in the second step, the entire system is delayed. T minus 1 is equal to e power x of t minus 1. So both are equal. It's a time invariant system. Got it, my students? So linear time invariant system. So time variant and time invariant and linear and non-linear we discussed, and we can see the some examples also. Now combine the time variant and time invariant with the linear system. So linear time invariant system. Any system obeys the linearity and time invariant property is called linear time invariant system. So individually we learn that is a linear system and time invariant system. So combine these two, you can call it as a linear time invariant system. Linear time invariant system means any system which obeys linearity property and the time invariant property is called linear time invariant system. And linear time variant system. Linear time variant system means any system obeys linearity and does not obey the time invariant. But it is a linear, but it does not obey the time invariant. So we call it as linear time variant system. Okay, let us assume here one example in this, y of t is equal to a into x of t. So first of all, I am finding the linearity. So a into y1 of t is equal to, so individually it becomes off with the input x1 of t, you get the response y1 of t. With the input x2 of t, you get the response x2 of t. Combine the function as y of t is equal to a into x1 of t plus x2 of t. Okay. And before giving to the system, you can add the two signals. Then after that, you can pass the signal to the system. You'll get the same function. So a into x1 of t plus x2 of t, and here also a into x1 of t plus x2 of t. System is a linear system. And also for the same function, the y of t is equal to a into x of t. Find the time invariant or time variant also. In the time invariant function, first of all, the delay the input signal only, the x of t minus 1, let it be the s1 minus 1. Okay. And entire system is delayed. Y of t minus 1 is equal to a into x of t minus 1. that is S2. So both are equal, time invariant system. So combine this function y of t is equal to a into x of t. It is linear and time invariant, means linear time invariant system. Linear time invariant system. So similarly, the other examples is two here. Y of t is equal to t into x of t. See, y of t is equal to t into x of t. T into x of t. So in the linearity, the signal is x1 plus x2. Before giving to the system, you can add the signals and individually can add the signals and give it to the system also. Both the functions will get the same. So it is a linear, definitely. But it is not the time invariant, because the delay function, the entire system is delayed. Y of t minus 1 is equal to t minus 1 into x of t. What it minus 2? This is a time variant. So combining the two functions, linear time variant function. So see here the linear time variant function, because it is a time variant, not the time invariant. And a into x of t plus b. A into x of t plus b is a non-linear system. Non-linear, but it is a time invariant. So we don't call it as a linear time invariant system. It's a non-linear time invariant system. And this is also the a into x square of t. X square of t function is non-linear, and x square of t function is in the time invariant and time variant is a time invariant. So non-linear time invariant function. E power x of t also. So e power x of t is a non-linear. Okay, we already seen. But e power x of t in the time variant and time invariant is a time invariant. So combine the function, the non-linear time invariant function. So x of t minus t naught is a linear time invariant. X of t minus t naught. It is a linear function. Understood? Understood. So any system which obeys the linearity and the time invariant property is called the linear time invariant system. Any system which obeys the linearity but does not obey the time invariant, but has a linear time variant system. And any system which does not obey the linearity and obeys the time invariant means a non-linear time invariant. What it matters?